So, number 8. How do we start it?
Nothing goes into all of them.
Right.
So you move over.
You just work it normally then.
Yeah, just work it normally. What do we move first?
6, 7.
67. So we have 2x squared minus 5x. Oh, this is such a fun one. Equals negative 67. We have to have the lead coefficient as 1. So that means we divide everything by 2. All right? So now we have x.
Can we just do 2.5?
No.
I hate fractions.
Okay, I'm just wondering why.
Because we're gonna have to then square it, and it just,
Well, we can put that in the calculator.
well, you're gonna be able, well,
Can we
Why
pick
is-
either big calculator or no fractions?
it's gotta be, you'll need it as a fraction.
Dr. Graham.
Because in the end, you're going to have, hold on one second, you're gonna have simplified radicals, not
Without
decimals.
fractions.
Why is 2 being divided by 2?
Because you need it to be a lead coefficient of 1. So everything gets divided by 2. So we have because when you factor it, you need it to be where we can have it simplified. We need it to, we're solving for
I thought
x.
usually we put it in parentheses if we do that then. No.
Not on that, because we did it to all of them. So then we're needing to solve for x, so we need to remove whatever we can.
Can you just do that on all of them? Like just divide by the lead coefficient? Okay.
It just gets a little gnarly on some of them,
Alright.
which is like this one, we're gonna have it, it's going to. So we have x squared minus 5x. Now, what do we do to that middle number?
Divide by 2 squared.
All right, so we're gonna have y'all, I know it's in there. We're gonna divide it by 2, which means multiply by 2. Okay? And then what happens when we do that?
Negative 5.
-5. And then you're going to do what to it?
Square it.
All right, hold on, I lost something.
Yeah, you kind of lost me, Doc.
Hold on. -5 over 2 divided by 2. It means multiply by 2, which is -5. And then, oh,
F of X, plural.
yeah. All right.
Might shut some out.
Huh.
That's all I needed. Yep.
All right, so
I'm big ass.
how did I
I got a big ass.
cut it in half?
Maybe she has some little hands.
I feel like I've done something.
My feet are big. Yeah, respect.
Would it not just be 25?
Okay, cut it in half and then square it. All right, I did something weird when I worked it. 2, and I got 5 over 2. But then that's going to be 5 over 4. That's what it is. X squared minus 5 over 2, and we'll have negative 67 over 2. Half. Oh, okay. Okay. I know where I am now. Lost my train of thought. Okay, negative 67 over 2. When we cut 5 over 2 in half, that means multiplying by 1/2. So that means x squared minus 5 over 2 times 1/2 gives us negative 5 over 4. All right?
You mean 2?
Wait, why are
4.
you doing 1/2?
Where
We're
did four come?
multiplied by 1, cutting it in half, multiplied by 1/2.
Why'd you do that?
Oh, because
Because
you're
you're
dividing
dividing
it.
it.
Divide by 2, multiply by 1/2. So this becomes 5 over 2x. And then it's going to be plus, when we take this, 5 over 4 and square it, what do we get? 25 over 16. All right, before we go any further, do you see where we got everything? This is a kind of an ugly problem.
So
Okay.
why'd you double it?
So then when we added
No, no,
20,
Why'd you square that?
because you cut it in half and then square it to make the last number every time. Cut the middle number in half and square it.
Okay.
Like we did over here. Move. Oh. There we go. Over when we worked this one, we cut 2 in half and squared it and got 1. All right. So back over here. How did we get 25 over 16? We squared 5/4 because that was cutting that in half and then squaring it. And then that means we've got to add 25 over 16 to the other side, which means we need a denominator of what?
16.
16. So negative 67 over 2, we have to write the equal fraction for that. And I will just go ahead and tell you that that is 536.
Are you gonna give us one of these on the test?
Sure. Well, why wouldn't I?
Seems quite hard.
No. And then plus, so there's a negative, 25 over 16. So then what do?
You add them together.
We add them together, and I will just tell you it's 511, and it's a negative
Speak good boy. You're adding?
over 16.
And that's simplified.
511 actually is prime.
Oh my gosh.
I know. So, what's on the left side?
A good number.
X
Mm.
squared minus 5 over 2x plus 25.
So what did we square to get 25 over 16?
5 over
5 over 4. And so that's what's going to be left inside here. And that's what we would have squared. I'm going to remove it from right here. And now we take the square root of both sides, which gives us x minus 5 over 4. And it's going to be plus or minus. We have a baby I, radical 511. Square root is 4. And then we're going to bring the 5 over 4 over as a positive. So your final answer is a positive 5 plus or minus baby I 511 all over 4.
Wagon man. This is your battle.
Hey, wagon, stay here.
Does it click? Did I lose you? Where'd it go? It's a lot.
Like a-
It's a
I
lot.
know it's you, Luke.
Look at these. These are a few
Get your
more.
haircut, wagon. You look homeless.
Wagon.
Yeah.
Oh, don't do that.
Wait, so what'd you do with the negative 5 over 4? What'd you do with the bottom 4 right there?
They have common denominators. 5 over 4, 5 over, and then the 4. So you just put the 5
Oh,
up
you went
here.
over there and went over the- Okay, gotcha.
Now, let me see specifics.
It's right here.
1.
You ever seen the video? Hey, Paul, what you feel like?
Look at 5.
I I see that. Yeah. Doesn't he smoke? Doesn't he smoke?
4.
Good for her.
Wait, I have to turn this into.
Our bill have
So
67%.
you're
I still do emergency roll that.
I would say that.
What did you do with that, Harper?
I want it.
Yeah. Takes
Claire.
passes it out a little.
That's still something.
What is this website?
It's okay.
Is this where you get your worksheets from?
Well, this is where where I load them. I have them elsewhere. It's just where I load them up.
So like,
All right, look at number 4. Does everybody have a sheet? All right, look at number 4. Let's rearrange it.
Get rearranged.
5x squared plus 10x plus equal sign plus 21.
Plus 10x plus 21. Well, we can go ahead, yeah. Equal plus 21. So
how'd you keep the 10x positive?
because I think I was listening and not looking. My bad. Thank you for catching that. 5x squared minus 10x equals positive 21. Now, stop. Not today.
I was being touched.
I noticed. So what is the first thing we're going to do?
Pencil.
Take out a 5 only on the left-hand side. And that gives us our x squared minus 2x.
Oh, you can.
Now, here we go. Take half of 2, square it. And that gives us what?
1.
1. But what am I going to add to the other side? A 5. So that gives us 26.
Why would you add a 5?
Because you agreed that we got the 1, half of 2 and then 1. But what is 1 really? It is 5 times 1. And then what, go ahead and rewrite that. Then what do we do?
26 and
26 divided by 5. So what is our trinomial factored? What would we get?
X minus
X minus 1. Sir?
Yeah, when would you ever use this in real life? Was this necessary?
I will say,
Math teacher, duh.
yeah, you want to be doing this.
And
Um,
then carry on.
And there are actuary things, actuary science that uses this. They do predictions.
It's 26.
Oh, it is, thank you. I'm wanting it to be a 25. I want it to be a 25. All right, 26 over 5. All right, then what do we do?
Add 1.
Take the square root.
We take the square root. This gets even more fun. So the square root on the left is x minus 1. That works nicely. 26, is it? Can we factor it into anything perfect? And then 5 we know is prime, so it doesn't. But the kicker is, Luke,
You're not done.
shh, you can't have a radical in the denom. How do you make the radical go away?
You have to radical
Times it
to
by
the top.
Times it, well, you're going to times it, multiply it by radical 5. Because now we have 26, and it's over our radical 5. And the other problems, we were able to take the denominator and it was a perfect square, and we would have a radical only in the numerator. Now we have a radical in the denominator, and you can't. So we're going to multiply the whole thing by radical 5 over radical 5. And y'all have got to remember my chant, maybe not, from 9th grade. Radical 5 times radical 5 is radical 25, which is 5. Radical 2 times radical 2 is radical 4, which is 2. Yeah, so Mercy, where were you? Just not with us. All right, so radical 5 times radical 5 is radical 25, which now gives us 5. But what is 26 times 5?
Big old number.
130. Okay? Are y'all good with how we got that? You see why we did it and where it came from? It's still a positive. 130 does not break down. Okay? So, and I can put a plus minus here. Now, what do we have to move?
The plus one.
-1.
The -1, and it comes over as a
Plus one.
positive 1. But you're almost right.
I was still stuck on the lines.
And
Or
Harper?
you just said an I.
No, I said there is no I. It's a positive. That 130 is positive.
Yeah, that's what.
Look, bro.
So, we're going to take X and we're moving a positive 1. But guys, we need the denominators to be the same. So what is 1 going to become? 5 over 5. So it's 5 plus or minus radical 130 all over 5.
All over.
All over. Make sense? No. All right, Trip, where'd I lose you? No, well, all right, just walking through it. Do you understand?
I understand this.
So it's Sarah.
Once you get there, I'll find out.
All right, good here. You remove the 5,
Yeah. I'm good
but you
with all
can't
that.
remove it from the 21.
Yes. I
So-
know until about where you start to get the square root.
Do you, and you got the 5 times 1 is 5? And then you divide it by 5?
Yeah, I get all that.
We're good with that.
Just
Once
after
you
that,
leave the
where
phone over
it's-
there, group dividing.
I didn't leave it down here. Okay, I'll do this. Hold on, that may help. Divide it by 5. There. All right, then you took this, you write it as factors. So X,
the- where-
X minus 1 squared, that makes sense? All right, and then it equals 26 over 5. Then you take the square root of both.
How do you know when to do that?
When you have, right after you factor, you then
Both sides.
take the square root of both sides. Most of the problems we've had, the denominator has been a perfect square. So we would be done, it'd be easy. This time it's 5 and it's not, but we can't leave a radical in the denom. So X minus 1 makes sense? It's the factor, okay? Then it's 26 over 5, all inside the radical.
Yeah.
So to remove the denominator radical, multiply the whole fraction, numerator, denominator by radical 5. So that makes radical 5 times radical 5, that makes our denominator now plain 5. And then 26 times 5. Because they're both radicals, multiply 130. But it stays a radical because there's nothing in it that's a perfect square.
Okay.
Then we're ready to solve, isolate, finish doing that with X. Minus 1, so it becomes plus 1. So technically it looks like 1 plus or minus radical 130 all over 5. But we need that 1, that we can rewrite 1 at any number over itself. So we rewrite it as 5 over 5. So that there's a common denominator, and we just put 5 in the numerator right there. Now you can't break the 5 and 5 down. Like we can't factor it because there's a 1, understood 1 in front of the radical.
Okay.
All right.
Yeah.
Kinda?
It helps.
Okay. Let us see. What would be? Oh, 7. 7's interesting. Y'all work 7. Because it's one that you can't remove the 2, so you're going to have to divide by 2. I know, isn't it fun? Okay, I know. No. Oh, yeah.
Probably just no. 8.
Do 8, and then we'll come back to 7. Do 8. I want you feeling comfortable with this. 8 will be less complicated.
So whenever you're doing the 3 over, did you just move the 3 over to the right?
Move move the 3 over and combine it with the -1. What did you ask? I'm sorry, Bella Vance. Okay. Yeah, don't bring the 1 over and then move it back. Yeah. Now, you will have a radical as part of your answer. It won't be a perfect number, but this one's, there's denom of 1. I mean, it'll be easy.
I'm trying to think what
Plus nine.
Okay, so
Uh-huh.
factor it and get what it's equal to.
And then so you'd say positive 9 minus 4 on the other side.
Uh-huh.
Which
So
is
that's
5.
equals
So we have 5.
3.
And then you factor, which is x minus 3.
Minus 3 equals 5.
Uh-huh. Then you
That's
take
and then I just
the radical,
Oh yeah, so you have x minus 3
radical equals
equals radical.
because it's really x minus 3. When you factor it, x minus 3 squared.
But 5's prime.
Yeah.
So what do you do?
So it's going to stay inside the radical?
Is it gonna be x squared minus 6x minus 3 equals -4?
X squared minus 6x plus 9.
Is it 3 plus or
Where's the
minus
9? Because
radical
you
5?
do.
Half
you
of
do
6
half
is
of
3, and then square it.
And square the 3?
Yeah,
Is it 3 plus
Plus
or
or
minus
minus
radical 5?
that's it.
Is it
That's the
plus
answer?
or minus for 9?
Do what now?
Is the 9 plus or minus?
It's always plus. Because it's, squaring the same number, you'll always get a positive number.
Can you put it all into the same radical? Like,
I'm so confused.
All right,
can you bring
all right, I'm going to write it super quick. This is,
Could I have just done radical x minus 3 squared equals 5 all under the same radical?
well, you have that equal mark in the middle, but probably. I mean, so you would have x squared minus 6x equals -4. And then x squared, half of 6 is 3. 3 squared is 9. Plus 9. Guys, be quiet. That's shouldn't have written the radical yet. I was in a hurry. Come here. There. And then that's 5. And then when we factor our trinomial, it's x minus 3 squared. Then we take the radical of that. So that's x minus 3 equals positive or negative radical 5. So the final answer, 3 plus or minus radical 5. Does that work?
I was just okay.
All right, where'd I lose you, Maya?
Oh, I just didn't know.
All right, but did you say you took half of 6 and got 3,
Yeah.
and then squared that and got 9? All right, when you
X squared minus 6x minus 30 equals 5.
not minus 3.
Wait, so when you,
Wait, hold on 1 second, Trip. You said half of 6 is 3, but then 3 squared is 9.
So you put that for both of them?
So it's
Put
going
that on
to be,
both sides?
and then that's what you add. You add the squared number to both sides. Trip.
I was about to ask.
And then that's how we got 5. But then when we took the square root, so hold on.
How'd you take this?
Hold on, let me back. I won't add that step by itself. So then you factor this.
Wait, so you factor the x squared minus 6x plus 9?
So you took half of 6 and 3 and then squared it and got 9. Now we need to factor that. 2 factors that equal 9, that when you add, you get a -6. So hold on, let me erase. X minus 3, x minus 3.
So you just put x minus 3.
And I just write it x minus 3 squared. But you can do it that way, if it's visually works. And then that equals 5. Okay? Then we're going to take the square root of these, which means one of our x minus 3 duplicates drops out. And then 5, we can't break any further. So plus or minus radical 5. Nope, the negative 3 moves over as a positive 3. So 3 plus or minus radical 5.
Is that because it always has to be x equals nine?
Yep. Got to isolate your x. Okay, when we were factoring, we would solve by taking the two binomials and making them equal 0. And we would come up with an answer. We did quadratic equation, came up with what x equals. That's your solution. We're doing completing the square. This is another method for finding what x equals. Okay?
Is it always gonna be plus or minus?
Yes, because when you take the radical, we don't know if you did plus, like 2 positives or 2 negatives to get there. All right. Work 9. In this case, will 3, you want to divide.
Yeah, can you break down that 3x? But do you,
Yeah, I broke it down and I moved it over after.
This is lovely when they all 3 are divisible by 3. So you're not going to have to multiply by 3 and then divide by 3.
Shoot, what's 51 by 3?
17.
That.
So I mean,
You divide 51 by 3?
yeah.
Do what now? I'm sorry. Yeah, divide it all by 3. This one works. Oops.
You mean negative I?
No, because the I means the negative. So what are we going to add to both sides?
4.
4. Half of 4 is 2. 2 squared is 4. Good.
Okay, so.
Do you just completely drop the 3 if they all divide by 3?
Wait, say that one more time?
Do you just drop the 3?
Mhm.
So it's just gone now?
Mm-hmm.
You get it? Do you know? So then you just take one. You just take x minus 2 equals negative 13. And that's it. But then this becomes square root. And you can't
What's
write
the
it
answer?
down, so it's just x minus 2 equals negative 13.
Yeah, what's the
I can't make my pen right.
Wait, do you have an x to the same on all?
What? What is that?
So what did you get as the final answer?
Negative 2i plus or minus 13. 2 plus or
Your 2 is going to be
minus
positive
five.
because it's x
So
minus 2.
2i plus or minus 13.
No.
I got 2 plus or minus radical 13.
X equals 2 plus or minus baby I radical 13.
Positive I.
Because it was a negative 13.
Oh, plus or minus I radical 13. I put the 2. I put the I one.
The 2's positive. Don't mess with it. Even if it came over as a negative, it's a baby I because the radical was negative. And it stays real close to that radical sign. The baby I does. It's attached to it. Even if we could factor, let's say maybe we had 20, negative 20. So if we had radical 20,
2 radical
and that's going to be 4. So 2 radical 5. And if it had been a negative 20, it would be 2i radical 5. The I is just always up next to it. Yes, ma'am.
Can I do then I said I need to go change my bottles.
We've got one more thing to look at. But I'm warning, are y'all good with this? Okay, I'm gonna assign one for homework, but
I just don't get the ones where you have to divide.
I just get stuck whenever you have to take it from the factoring into the radical.
Like, I don't get like when you take, like, the number on this side and like divide it by the number on the other.
okay, if you were able to break down the left but not the right, then you're gonna have to distribute that number, that factor, to the, whatever you squared thing, and put it over there, then divide by.
So say this one was like that, but 51 wasn't divisible by 3, then you'd still divide it by 3.
You would move it over there, divide by 3, x squared minus 4x, but you'd have a 3 out here.
Yeah.
And then it would be negative, there would be 3 times 2, because we had it like a 2 over there. 3 times 2 is 6. We would add 6 to it. Then divide by 3. Do you have one yet? Take it and run it around.
Oh, yeah, we do. Oh, we're still recording? I didn't know.
Yes, we're still recording.
Everyone's saying
A little bit. So, what is the discriminant? Do y'all recall?
It's the opposite. Wait, no.
That's conjugate. What part of quadrilateral, hold on. Quadratic equation. What part of this quadratic formula is the discriminant?
B squared. 2A. Or AC.
You're using your phone. All right. So, what part of this is the discriminant?
Opposite B.
the radical.
All right, this is kind of our,
Opposite B.
that's our vertex part.
So it's B squared minus 4.
It's the part underneath the
Was that
radical.
hidden during the cliff or the quiz?
So, this is the discriminant. Radical b squared minus 4ac. So, radical b squared minus 4ac. That part of the quadratic formula is considered the discriminant. Now, when we work it, that means we're taking 4 and multiplying it by your a and your c, and then finding the perfect square of b and combining, whether we're adding or subtracting. You're going to get specific values underneath there. If we end up with a perfect square under here, like we end up with 25 and we can say it's a 5, then you're going to have, and this is a hard, fast rule. What's a root?
Your ace.
How many times?
It's crossing the x-axis where it touches the x-axis. You are going to have 2 roots, and they are both going to be real numbers, and they're going to be rational. In other words, you can divide them. Okay, so like we would get 4 and 2, or 2 negative 4. If it is still larger than 0, but it is not a perfect square, you will get 2 roots. They will be real, but they will be irrational. In other words, they're going to have that radical part in there. If it equals 0, there will be 1 root. And it will still be real. And it will still be rational. Shh. If it's less than 0, what do we have under there?
0.
Less than 0. If under the radical, it's less than 0, what do we have?
No roots.
But what does it look like?
There's an I.
There's an I. There's a baby I. So there will not be a root. It will not, you can graph it, but it will not touch the x-axis. And you will have two imaginary answers. Hence the baby I. Now, okay. Work just the radical. Work just the discriminant. I gotten tickled. Work just the discriminant for number 1, Stella and Bella Vance. For number 2, let's see, Ann Harper, Claire, and maybe Mercy. Number 3, Maya, Cushy, and Tripp. Number 4, the couch potatoes. Mm-hmm.
Is this just the regular working?
No, just the discriminant part.
It's just b squared minus
B squared minus 4AC. You're not having to do the opposite B and all that.
Wait, for
You're,
which question?
y'all were 2. So this is where you're only doing B squared minus 4AC.
Wait, you moved 13.
Yeah, you have to move
Well, that's your, no, you want it in standard form. But you can have a negative A. Well, now, this isn't completing the square.
Wait, ours doesn't have a B.
Yes, it does. 16.
No, it doesn't.
16.
Number 2?
Oh, I thought we were doing 4. Just kidding.
No. The couch potatoes are doing 4.
Yes.
At this point, you should just like buy couches instead of tables. I mean,
Yeah. You should buy just like one big couch.
yes.
Everyone gets one.
I got it.
Hold on. Don't say it.
Would, on number 3, would it be, is it 0?
Zero?
Which one?
Oh,
I didn't finish drawing that. I didn't do
You're doing just the radical part.
our future house.
But we're going to find the number. Don't take the radical of it yet. I mean, I guess you can. Yeah, go ahead and take it out. Perfect. You got 248.
We got 0.
All right, you got 0. What'd you get for 3? 38. What'd y'all get for 4? You should have got negative 288. All right, so that's the hint part with your answers for what you would get. Like this one would be 0, so you would have one root once you work it out.
So, I added you someone.
All right, Maya, I haven't dismissed. Hold on, let me stop.